Good morning, COIC. How late were you guys out? That was terrible. Good morning, COIC.
Good morning.
Yes, all right. My name is Dan Vega. I'm a Spring Developer Advocate at Broadcom, and we're going to talk about MCP today. This is going to be a gentle introduction to MCP. Even if you are not a Java or a Spring developer, you'll still get a lot out of this because we're going to go through some of the fundamentals. We'll look at some code in Java and Spring towards the end, but that will really kind of translate to whatever language or framework that you're using. Now, I have a little friend up there, that cute little robot. His name is my cool pal. That's how I refer to him. And he's going to help me out in this presentation, so you'll see him throughout. So we're talking about Model Context Protocol. This was released in November of 2025, so we're not even a year into this. And this has really got some traction in the industry. You hear MCP a lot these days, and rightfully so. And we'll talk about what it is and kind of what problem it's going to solve for us. So if, we start to break this down. We start with the technical part of this, which is a protocol, right? This really defines how an AI talks to, or how we talk to AI models in a consistent and structured way. So we got the technical stuff out of the way, which leaves MC. I got a little bit of a confession to make. When I'm writing articles, when I'm creating videos, when I'm preparing for talks, my mind starts to wander a little bit sometimes. So I was looking at MC and I'm like, oh, what are some other things that start with MC that I really love? Who doesn't love a good breakfast sandwich, right? From McDonald's? I grew up in the MC Hammer era, so I love a good pair of parachute pants. And finally, McLovin, this wonderful character who created a fake ID to buy his friends alcohol. So, okay, my mind's wandering a little bit too much. Let's try and bring it back, right? We're talking about here is Model Context Protocol. We talked about the protocol piece. The context is, hey, we're really trying to supply these large language models with some context. Here's a little bit about me. I'm from Cleveland, Java champion, software developer for a long, long time. I've worn a lot of hats. One of the favorite ones I'm wearing is the one I'm wearing right now, which is of a Spring Developer Advocate. I'd like to echo some things that Aaron Francis said this morning. And I like to tell people that you do not need permission to advocate for the things that you're passionate about. So if you're interested in something, you don't have to ask somebody. Go write an article, create a blog post, create a video on it, go out and tell people about it. This being involved in the community and talking about the things that I enjoy talking about has led to so many things for me, and I just kind of want to echo what Aaron said this morning. Soon to be author, Fundamentals of Software Engineering with my good friend Nate Chuda comes out later October, maybe early November, so if you're interested, you can check that out. So I want to start with a problem statement, which is, how do we augment the limitations of large language models? For all the good that comes with large language models and the things that we can do with them, there are some limitations. But if we know what the limitations are, then we can point the right tool, tweak the right knobs to get what we want out of them. So what are some of these limitations? We know about these, right? Hallucinations, it will invent facts or API names with total confidence. It has stale data. We understand that it's trained on a certain set of data up to a certain point, so it doesn't have access to real-time data like, hey, what's today's stock price for this particular ticker? It has bias and safety. It was trained on the entire internet, and guess what? The internet is biased. It has stereotypes, right? So we have to be sure that we understand this going in. It has domain gaps. So it may use generic wording where niche jargon is required. We have this thing called the context window. We're filling up the context window with our messages, with the responses from the large language model. And when this happens, and we get large context windows that can get truncated and previous conversations can be forgotten. Non-deterministic. We can ask the model 10 times the same question and get 10 different results, right? Things like privacy and security. We don't want to leak proprietary information or personal identifiable information out of our trusted boundary. As we're starting to build these applications, we have concerns around costs and latency, right? And sometimes we can have weak reasoning. If we have these large, like multi-step calculations or logical deductions, it can take the wrong approach to this. So these aren't all, but these are some limitations of large language models. And again, as long as we understand this, that's okay. We can kind of point the right tool at these problems. So I want to take a look at this. We understand that it's not trained on data up to a certain up to a certain point, right? So I'm going to go out to Claude and I'm going to say, hey, how many total sessions are at Commit Your Code this year? We understand it's not trained on this data, right? So what it's going to do right away, it understands I'm not going to be able to answer that. I need to invoke a tool. And one of the tools that it has to do this is to go out and search the web. So it's going to start searching the web. If it doesn't find the right answer, it's going to go do another search. It's going to try and get the context that it needs to correctly answer this question. Now what it's going to do is it's going to go through and search and say, okay, based on some search results, here's what I can provide you. There are 125 sessions through 4 tracks. There are also workshops that are 2 hours long. This sounds right. If I didn't know any better, this is good. I don't think there are any workshops here. If I counted correctly, and I think I did, there were something like 62 if you include like the closing keynote, there's 62 sessions. So while this answered it, it didn't answer it correctly. And because it didn't have the context that it needs, right? So I like to think of LLMs as super smart interns. They can design entire design documents in seconds, but they'll also confidently tell you the Eiffel Tower was finished in 1875, which it wasn't. It was 1889, right? How many times have you worked with some type of a large language model or agentic coding agent and said, hey, build some code for me, and it writes out this code, and you know the APIs pretty well, and you're like, that is not an API that I'm aware of. And it goes, no, this is what you should use. And you're like, oh, that's not real, right? It's very confident in the answer that it's giving you because this is the information that it's trained on. If you go, that's not a real API, it'll go, oh, you're absolutely right. Let me go try and search the web again and find the right answer for you. So they're extremely confident and they're not trying to trick you. It's just the information they have at hand to give you that answer. So one of the ways that we can combat some of these limitations are through something called a tool or a function call. And when it comes to tools, there are primarily 2 uses of this. One, I want to retrieve some information and provide that as context to the LLM, or 2, I want to take some action. So when it comes to information retrieval, we could talk to external sources, we could talk to a database, a web service, some type of search. And the goal here is to augment the LLM, allowing it to answer the questions that it would not be able to without this information. What is tomorrow's date? What is the current weather? What is the stock price for this particular ticker? The other thing we can do is take action. So tools can be used to send an email, create a new record in a database, submit a form, trigger some kind of workflow. The goal here is to automate tasks that would otherwise require human intervention or explicit programming. So that's really what tools are when we talk about building kind of generative AI applications. So here's an example. Again, this is in Java. This will work in kind of any language, but what I'm going to ultimately ask the LLM, what is tomorrow's date? If we did that without any kind of intervention, it wouldn't know because it doesn't have the context of what today is. So I'm providing a function that can get today's current date based on the time zone that we're in, right? And the important part here is the description that we hand off to the LLM. So when we define a tool, we give it a name, we give it a description. We don't want to be very exhaustive with this, but we also don't want to be very short with this. We want to give it enough context so that when it sees this description, it knows what this tool is capable of doing. And this is a diagram from the Spring AI documentation, but again, this kind of works across whatever language you're using. And the way this works is before we send off a request to a large language model, we have this tool definition, and it has a name, a description, and a schema. So we send off a request to the large language model and say, what's tomorrow's date? It says, I don't know how to answer that question. I do see you have a tool defined here, and based on that description, I think we can answer that question. So I'm going to send this request back to you. It's your job now to kind of invoke that tool and get the response from that tool, and now add that to the context. We send that back to the large language model, and now it's able to answer that question. An important thing to remember here, though, is that tools are selected by the model, not by you. You don't say, hey, run this tool. You give it a number of tools, and based on those descriptions, the large language model will determine which tool it needs to call, or you need to call, to answer that question. So this is where we have to start thinking about some things. AI can have some difficulty determining which tools to call, especially in like multi-step tasks. Sometimes they may select the wrong tool, and this isn't a single universal limit, but it may come down to different AI systems, and this may be something that improves in the future. But you don't want to overload a system with a number of tools. So don't just say, here's 100 tools, pick from them, because it might not pick the right one. And again, if you have descriptions that are kind of close to each other, it may not pick the right tool for that job. Generally, 5 to 20 core tools is a good number. Again, just try not to overload a large language model with a number of tools to select from. Okay, so that's kind of the limitations of large language models. That is tools, that's one way to kind of solve that problem. Now we can dive into model context protocol. So we're gonna start with just some of the building blocks of like building MCP servers. Again, back to what is model context protocol? It defines how we talk to AI models in a consistent and structured way. I like to think of this as HTTP for LLMs, right? It's a standard format for sending and receiving requests to models, no matter who makes them. And I mentioned at the beginning, this was started by Anthropic. This is not specific to Anthropic, right? This works across a lot of the large language models. Again, the motivation here is models are only as good as the context that you provide them. So some of the benefits of MCP, I like to start with modularity, right? This lets the AI app stay light while being deeply aware of your environment that we add to it. Reusability, once you write an MCP server, say one that surfaces project files, you can serve that app to any app that supports the MCP protocol. Language agnostic, we are looking at Java and Spring today, but that doesn't matter, right? Once I package it up, I can package it up as, say, a native executable, and you can use it without having any idea what Java is. We can also, I use a lot of MCP servers from Python and from TypeScript and Node, right? Language agnostic is a really good benefit. We get fine-grained control. It gives you programmatic control over what the AI sees and what it can do. So we don't have to give it like everything, we can just give it what we want to give it. And again, privacy and security, if we have a lot of like documentation or personal identifiable information that we don't want the large language model to see, we can make sure that we control that. Okay, so let's talk about some of the components of an MCP server. So we have a host here. So these hosts could be things like Claude Desktop, Claude Code, IntelliJ, VS Code, Cursor, Windsurf, whatever supports the MCP protocol. Then we have the client that makes a connection to the server. So Claude, let's take the Claude Desktop example. This will act as an MCP host. Claude establishes a connection to an MCP server, such as the GitHub MCP server. And then the Claude Desktop runtime will instantiate an MCP client object that maintains a connection off to that MCP server. So wherever we are using these, we have the host, which is our app. We have a client connection that is made to the MCP server. One of the questions I get all the time is, okay, this is great, but how is this different than an API, right? Can I just take my API and make it an MCP server? And the way I like to think about this is that MCPs are provider agnostic, right? We are wrapping things like OpenAI, Google Gemini, Mistral in one common format. The core value proposition here is that MCP transforms AI integration from provider-specific information into standardized interchangeable service layers. I like to think APIs are for systems talking to each other. MCPs are for LLMs talking to your data. Okay, so we learned about tools. How is MCPs different than tools, right? Because MCPs can use tools. So I have an example here. If I was building this application, Dan Vega as a service, right? And I went off to the LLM and I said, hey, what is Dan's latest video on YouTube? Again, we saw that before in the example. It is not gonna know. I don't have the context of that. I don't know what the last video is. I can't answer that question. So I could easily make a tool that connects to like the YouTube API and pulls down this information and add this as context. We saw how this works with tools, right? But what if I needed to like provide search? I'd have to create another tool for that. What if I had to like provide file system access? What if I wanted to surface information about my newsletter or my blog? I could do all of this inside of this single application, and that would work. But what happens if you wanted to use this in, say, Claude Desktop or whatever application you're using? You would have to go and repeat this in another app. So think about this from inside of your organization, right? You could connect to some internal application, pull down information, but then you would have to go rewrite this for the next step that you do it in. When it comes to MCP, we can write this as an MCP server and then reuse this wherever we wanted to. So let's start with primitives. Probably the most important concept when it comes to MCP. This is defining what the clients and servers can offer each other. The primitive types specify the types of contextual information that can be shared. Now, most of the time we hear about tools. We saw an example of tools. I can get some information, I can take some action, but there are actually two other primitives that we can talk about, which are resources and prompts. So we'll talk about these. So what are tools? We saw that already. Hey, I can perform some action, get some information. Here are some examples of it. I want to read a file, I want to write a file, execute some SQL, send an email, etc. These are, again, we want to get information or we want to perform some action. The next are resources. So these are data sources that provide contextual information to an AI application. So think about it as file contents or database records or API responses, something that we want to hard code in there that they can have access to. I saw a really good example of this. So somebody wrote an MCP server that was able to talk to a database and get some information back through natural language, right? Like, how many customers do we have using SaaS product 123? But then as a resource, they provided the database schema. So just the schema alone. So now, if I'm trying to interact with that MCP server, one thing I could say is like, how do customers relate to orders? And then through natural language response, we can kind of see that connection from the schema. So resources are just more information that I want to provide to the MCP server. And then we have prompts. So if we're writing an MCP server, you probably know how to use this better than the end user at this point. Maybe there's like a certain way that you want to write a prompt. And instead of having the user write out this long prompt to access that information, you could provide this prompt template. We'll see an example of that today as well. The important thing here is that to understand the interaction model. So we have prompts. This is user-driven. From something like Claude Desktop, they select a prompt and they execute it. From a resource standpoint, this is application-driven. From a tools standpoint, this is model-driven. The model selects which tool to invoke. Okay, so those are primitives. Then we have these things called transports. And transports are a way to provide communication between clients and servers. And there are really three transports that the Model Context Protocol spec provides. One is standard in and out, STDIO. And this is, hey, I want to build some like local integration. I want to build some command line tool. I just need it to work on my local machine. And then the other two are for building MCP servers that are going to be in the public. The first one is server sent events, and this was the first one to come out in the protocol, but has since been replaced by streamable. So not everything is supporting streamable yet. Spring does in the latest version, but you may see server sent events and streamable HTTP. And this is a way to take our MCP servers and put them out into the public so that we don't just need to run them on our local machine. Examples of this are like the GitHub MCP server, the Stripe MCP server, etc. Okay, so that's a little bit on how to do that in general, kind of some basic foundations. How do we do this in Spring? Well, if you go over to Model Context Protocol, you'll see all the different languages that are supported. Java is supported thanks to the Spring team. The Spring team donated the support for MCP to Anthropic. So you can go ahead and select that. So you don't need Spring. You can just use plain Java if you want. You can also use Spring to do this. From a Spring perspective, go to start.spring.io, pick a dependency. In this case, I'm going to build a web app, so the transport could be HTTP, and then just choose Model Context Protocol. From there, we get the things that we're used to using in something like Spring, right? We get a familiar and consistent programming model. with some additional MCP APIs, like we talked about, tools, prompts, resources, the ability to use those primitives in our application. What does that look like in code? I'm writing Spring like I normally would. I have this component, and then I just have this extra annotation here, this MCP tool annotation. And what this does is we define a name and we define a description. The example that we're going to look at today is a commit your code MCP server that provides more of the context so that it can answer that question from the beginning. But we're giving it a description. Hey, get all the conference data, including sessions, tracks, rooms, and conference details. Now, in this case, I probably should have included the name of the conference in there, but so be it. What this means is, because we're writing normal Spring, we're not writing anything specific here, we can write tests like we normally do, right? So we can test out that session tools if we want. Now, when I say test, that is kind of like automated tests, right? What if I wanted to like manually check out this MCP server, see if it's working? We could use an MCP client, we can test it in a host like Claude Desktop, or any MCP client of your choice. But there's also a really good tool out there called the MCP Inspector. And if you go to Model Context Protocol, you'll see this tool out there. There have since been other tools like this that have surfaced. But this is a really good way to kind of test out your MCP servers. Okay, with that, I'm going to show you some code. Let's switch here. And like I said, I built a simple application to hopefully answer that question that we asked at the beginning, because it didn't have the context of what are the actual sessions of this conference. So if we look at our sessions.json, I just went out to the website, scraped a bunch of data. Here's some conference data. Here are all the sessions that I found. I've created some records in here to kind of model that JSON data. Nothing specific there. And then from a Spring perspective, I'm just setting up some properties. In this case, I'm just building a local integration. So I said, hey, this is using that transport, that stdio, standard in and out. And so from this, now what I can do is just define some tools. So I have this single class called session tools. It is going to read some data from that JSON file that we have. And then these MCP tool annotations are what we are going to provide in the MCP server. So when someone loads this into, say, Claude Desktop, they can enable all these, they can turn these on and off, but these are kind of the public API that we're making available in the MCP server. So I have one to like get all the conference data. So this gives me conference, tracks, and sessions. I have one to, hey, I just want to split this out and tell me how many sessions are on each day. I have one to get by track, and etc. So we have all this information, and what I want to do is make this available in Claude Desktop. So whatever MCP host you're using, Claude Desktop, Visual Studio Code, there's a way to kind of add MCP service to it. From a Claude Desktop perspective, they have this JSON file. We just have to add a little bit of information. So you can see here I'm using one from one of the public, or one of the servers out there, which is using Node. And it's a file server system, and it gives some access to some certain paths on my machine. This is the one that I'm using for CYC that I built. So I've created a jar. You could create a native executable so somebody doesn't have to have Java on their machine. But once I have this, now I can go ahead and open up Claude Desktop. So let's go ahead and remove this. So let's say Claude. And there we go. So if we go in here now, if we go under these little gears here, you can see down here, I have this CYC. And I can disable these, but I know that these are the tools that are available here in Claude Desktop. I can also go over to this plus, and I have this CYC, and I have this prompt that I made available. So in the code, I also made prompts available. So now, instead of the user having to like type this prompt out, this prompt will go through and say, hey, using this tool, can you go like reference this tool and like answer the question like how many sessions are there going to be at CYC? So we look at here, day 1, 64, day 2, 64, 128. That doesn't even seem right. Maybe some sessions got moved off of there. But then I also provided some context with, hey, also provide some insights into the sessions for that day. So you can do that. But you can also go ahead and easily make this available to the public. So again, the streamable HTTP transport says, hey, we're not just building this for our local machine, we want to put this out into the public. So now if I went to, I think I have Claude up here. Yep, and then I can go in here and I also have that available here as a connection in Claude. ChatGPT also just made this available, so you can add MCP servers through ChatGPT. They have like a developer mode, so you can do this there as well. Okay, all the code that we went through today, github.com/danvega, CYC. And I think that's all I got. Let me just do this. Yes, okay. Feedback is appreciated, but if you have any questions, I'll be around the rest of the day. That is MCP. Thank you.